time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It's one small step for man, one giant leap for mankind.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
The following program may contain coarse language, adult themes, and bad attempts at humor. Listener discretion is advised.
What is President Trump's goal? What is his vision? He wants to put an American flag on Mars.
Houston, Tranquility Base here. The Eagle has landed.
I am JEFF, also known as A Cosmic Bard over on X, and this is the Lost Wanderer podcast for October 19, 2025, coming to you from the ACS Serenade Observatory, orbiting high above the night side of Earth. Tonight, rockets that almost touch perfection, nations turning orbits into advertising space, and a universe that just might be thinking about us as much as we think about it. There's a certain sound that only happens when a human creation succeeds at the edge of possibility. It's not the roar of engines or the cracks of plasma. It's that sudden silence in mission control when everyone realizes nothing exploded. Now, let me fix this one little thing here. Sorry about that. There we go. On October 9th, 2025, Starship rose from Boca Chica for its 11th integrated flight test. And this time the word was, quote, near perfect. For SpaceX, that's practically flawless. For the rest of us, it means one more line crossed off the list, or maybe 100, of things we thought were impossible. They say every launch is a symphony of 1,000 things that could go wrong. This time, almost all of them decided, we're going to sit this one out. Stage separation was clean at T+2 minutes and 45 seconds. All 6 vacuum Raptors burned steady. Telemetry stayed crisp, and the vehicle climbed past 200 kilometers before performing its controlled re-entry burn. 63 minutes after liftoff, Starship's stainless steel hull splashed down in the Pacific near Hawaii, the first time a full stack completed its integrated flight profile. And it hovered. It hovered before landing. And I'm sorry, it wasn't in Hawaii, it was Indian Ocean area. But it's kind of interesting to think that there was a time when rockets were miracles. In most of our lifetimes, they were miracles. When the first Saturn V left Earth, it carried a kind of a religious energy, thunder, smoke, and prayer. The entire Apollo era used just 13 of them. SpaceX can match that number of orbital launches now in just a month. The shuttle years made us casual about orbit. Falcon 9 has made us efficient about it. But Starship makes us bold again. It's not just a rocket. It's a monument to human stubbornness. Every panel of stainless steel reflects the sunlight like a mirror aimed at the future. Every weld, every energy bell is a small defiance against gravity's monopoly. And when it lights up, it's not subtle. It's the loudest reminder that our species is still reaching, still dreaming, still just a little bit insane. Now, that near perfect flight was more than a milestone, it was a sound of confidence returning. After so many fiery lessons, 10 flights that, well, let's face it, more than its fair share ended in tumbles, tears, and telemetry blackouts, they kind of got the rhythm right on this. I don't know what was louder, the engine or all the engineers at SpaceX exhaling at one time of success. Now, of course, while the headlines were shouting, SpaceX quietly fired off another Starlink Group 1059 from Cape Canaveral, just another Tuesday for SpaceX standards. Another 53 satellites tossed into orbit like seeds into an infinite field. In 2025, the cadence averages once every 3 to 4 days, a schedule that would make the shuttle program blush in envy. A decade ago, one successful launch was Champagne. Now it's, oh, right, that happened. But that's the weird part of progress. It sneaks up on you until the miraculous becomes, well, I hate saying this word, mundane. If you've stood outside on a clear night and watched those pearls of lights slide across the sky, you know it's impossible not to feel something. Awe, maybe, or unease. We're rating constellations that move. Some see it as innovation, others call it orbital graffiti. Either way, the sky is no longer silent. Our planet hums with metal, each node whispering pockets of data, memes, stock trades, and more often than not, arguments. The human condition has officially gone orbital. That said, there's still paperwork, because every revolution eventually has to file for a permit. In early October 2025, the U.S. Space Force authorized up to 100 SpaceX launches per year from Vandenberg Space Force Base through 2035. So for those on math, because it is Sunday and we do math here, that's an average of 10 launches from Vandenberg per year. Let's face it, this is no longer just exploration. This is infrastructure. That's turning spaceflight into logistics, orbit into a kind of an interstate. Somewhere in a Pentagon office, a colonel with a cup of coffee signed the future like it was just another requisite order. Maybe just that's a real milestone, the moment when our greatest technical marvels become part of the supply chain. If you're anything like me, we used to dream about launching rockets. Now we schedule them. The frontier has a flight manifest and a barcode. And I'll be honest, there is a bit of a strange comfort in that. Because it means the dreams of our youth survive long enough to almost get boring. And that's how you know a civilization is growing up, when its miracles become borderline routine. Fire once belonged to the gods. Now it cooks our breakfast. Orbit was once unreachable. Now it's a line item in the fiscal year. You can almost feel the planet exhale every time one of these boosters lands upright, shrugging off gravity like it doesn't exist or it's an old habit. When you think about it, Falcon 9 has now flown over 320 times with more than 250 successful booster recoveries. And some stages have flown missions 20 or more times. Every time those grid fins open and the rocket tilts into a controlled fall, and if you didn't catch the launch today, holy hell. It looks less like a technology and more like a choreography. And tonight's mission was the epitome of that, with a visual on the booster from launch to landing the entire time. Seeing the curvature of the Earth, busting through Max Q, where for a half a second Starlink lost communication and froze. The entire time beaming down high quality graphics we could never have dreamed of. And yet, they're happening. Of course, routine has its own risk. When the extraordinary becomes Tuesday, we do sometimes stop paying attention. We forget that each of these launches is a small rebellion against gravity itself, the oldest law we've ever broken. And it's easy to scroll past. Another flame, another tower, another cloud of steam, and miss that we're still writing the next chapter of the human story, one ignition at a time. Now, Starship isn't just about Mars. It's about proving the big, impossible things are still possible, like trying to put together a KLRN play. That ambition doesn't have to die just because budgets do. That maybe somewhere between bureaucracy and burnout, there is still room to allow ourselves to wonder. And sure, the memes will write themselves. Every launch gets a dozen Elon versus gravity jokes before the engine's even cool. But beneath the noise, there is an undeniable truth. Nobody else on Earth is flying machines like this. No one. Blue Origin's getting close. Now, the engineers don't post threads about inspiration. They're building it. Every weld, every test stand, every fuel line humming with liquid methane, all of it speaks the same quiet language. Let's try again. And somewhere right now, someone is probably tightening a bolt on the next booster, running a simulation, or dreaming of a rocket that can reach a place we haven't yet named. Because that's how this story goes. One launch at a time, one more flame in the dark. Momentum doesn't care whether we notice it. While we while we argue over who owns the sky, while governments drag their pins across orbital leases, somehow, some way, the engines keep burning. Factories in Texas, pads in Florida, control rooms in Hawthorne, all humming to the same rhythm again, 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 again. This is the same beat that drove the Wright brothers, that echoed in the VAB at Kennedy, that whispered throughout the launch pads of Bacanor and Tenasquara and Wenchang. It's the sound of humanity refusing to stay where it's comfortable. Because we're not very good at sitting still. Every age has its own frontier. This one just happens to start 100 kilometers up. The real trick will be remembering why we went, because the higher we climb, the easier it is to forget the view from the ground. We could build an entire civilization that orbits Earth and still never see it. Not really, if we forget what it means to look homeward. Maybe that is a price of progress. Each ascent takes us further from the world that built us. But maybe that's the reward, too. Sometimes distance can change your perspective. From up there, borders can vanish, politics can blur, and even the loudest voices of ego can sometimes fade into static. And maybe, just maybe, that's why I still get goosebumps every time a rocket clears the pad. Because for all the noise, all the corporate logos, all the memes and manifestos, there is still at least one unshakable truth. When the engines ignite, we all rise a little. The first spark is human, the second spark is hope. And by the time the booster lands, we've proven again that gravity is only half the story, that the rest of it is us. We build because we must, because every time we light the sky on fire and nothing breaks, the universe nods just a little and lets us keep climbing. And when the exhaust fades and the cameras turn away, the engines keep burning in silence, in factories and labs, and more importantly, in the imaginations of the people who refuse to be done. Every orbit, landing, near perfect test is just another verse in a song we've been singing since we first looked up and wondered, is there anybody out there? We have turned the wonder into welds and guidance code, into reusable miracles and burnt fingerprints, and still sometimes that is not enough. Because somewhere ahead, there's another version of Starship, sleeker, lighter, maybe faster. And behind it, another team, another spark, and another dream that refuses to stay grounded. The sky is open for business, sure, but it's also open for belief. And if you listen closely, above the noise of ambition and the hum of bureaucracy, you can still hear it. A faint, endless rhythm of engines. that never quite stop. Now, as starships roar towards tomorrow, orbit's oldest resident sadly is ready to dim its lights. After a quarter century circling above us, the ISS is almost ready to come home. For when a frontier becomes familiar, it starts to feel like home. For nearly 25 years, humanity's home above Earth has been a patchwork of aluminum and perseverance that is called the International Space Station. Assembled from more than 100 launches between 1998 and 2011, it has hosted over 280 astronauts from 21 different nations and carried out well over 3,000 scientific experiments. It has watched the sun rise 16 times a day, every day, since its late 1990s. Long enough for an entire generation to grow up never knowing an Earth without people in orbit. That said, even the best built homes wear out. NASA has confirmed the station's controlled deorbit for around 2030. After nearly 3 decades of duty, controllers will guide it into the South Pacific for a fiery farewell. The module is glowing like falling stars as they return every barred atoms back to Earth. Now, admittedly, it sounds brutal, but that's the way of orbit. Skylab lasted 6 years. Mir held on for 15. The ISS will have doubled that. Metal fatigue, seals age. Micrometeoroids stop never knocking on the door. And maintenance now costs roughly $3 billion with a B dollars a year. So the plan is to hand the keys over to the private sector. Instead of one vast government complex, NASA will rent time on a smaller commercial station such as Axiom, maybe Vast Haven 1, and whatever else follows. Now, Haven 1 aims to launch in 2026, small enough for a single Falcon 9 and designed to host 4 crew for a month. Axiom's first module will attach to the ISS before branching off to become its successor. It's sort of an odd kind of progress, leaving one grand outpost for a constellation of orbiting startups, kind of like a, well, the way I can describe it is a motel chain of low Earth orbit. But maybe that is the new shape of exploration, public dreams funded by private wallets. The ISS was born from ashes of the Cold War when Russians and Americans decided to bolt their futures together instead of maybe pointing missiles at each other, even though those missiles have been constantly pointed at each other. And for a generation it worked, not because of treaties, but because people kept showing up for work. The quiet cooperation might actually be the ISS's greatest legacy. But when the final module falls and the sea swallows the sparks, it won't be a funeral, it'll be a migration. A new astronaut will float inside a privately built module, look out a new window, and see the same sunrise the ISS crew saw thousands of times before. It's a hard fact, but home isn't the hardware. It's the habit of coming back to it. And whether the wall says NASA or Axiom or some other name, it's still the same thin line between humanity and the void. So when the station finally burns across the Pacific sky, don't call it an ending. Call it proof that we stayed. That for a quarter century, 30 years by then, we kept a human heartbeat circling the Earth. Now, while one, I can't believe I have to find this. Y'all are going to be so disappointed in me. I don't know. Oh, I don't know what to do here because it's not loaded up. Why is it not loading up? I don't know. It's like I'm unprepared. I'm never unprepared. I think you all caught me in a moment of unpreparedness. Mark this down. Because I don't have the music. While one generation of explorers prepares to bow out, another seems busy turning orbit into a billboard. It's once a time again for the crowd favorite segment where diplomacy meets dumb ideas, and the dumbass host of this show does not have the music ready, so I'm just going to say it. Let's go to Assholes in Space. Dun, 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 dun. Can't believe I don't have it ready. There's an old saying, space is hard. Apparently, it's also crowded, especially if you are China, who seems determined to turn orbit into a cosmic traffic jam. This week, Beijing pulled off a surprise long March launch, their 600th mission in the series, sending another batch of internet satellites aloft. Even state media called it, quote, ahead of schedule, unquote, which is code for, we didn't tell anybody, we didn't tell anybody. Now, international trackers scrambled to find out that, well, what just appeared over the Pacific? Should we be alarmed? Because if China's space program has a motto, it's basically go, surprise, everybody. Now, it wasn't just a single launch either that was to be noted. Private Chinese company CAS Space tested a new sea-based rocket, firing off the deck of a converted offshore barge. Oh, yes, this is the same technology SpaceX toyed with a decade ago, and the Chinese stole, borrowed, whatever. Only this time, there's a giant red flag painted on the hull of this vessel. In theory, sea launches reduce the risk to land populations and, more importantly, cow populations. And it's also, in practice, they let you drop, spent boosters wherever you want and call it international water. That said, they're not done yet. While the rest of the world was clapping for Starship's precision landings, CAS Space quietly announced plans for a bigger payload capacity and rapid reuse systems. Essentially, a Starship Light, which they probably stole, borrowed, took, whatever, the plans from. So yes, while Elon's making memes about Mars, Beijing seems quietly building the Wish.com version of Boca Chica. And at the same time, the CSA, the Chinese Space Agency, has begun testing new deorbit systems, robotic arms, and drag sails meant to collect orbital debris. Yes, Al, if you're listening, they're stealing your idea, because that's what they do. They steal everything. Now, on paper, it's a noble goal. Less junk, safer skies. Until you remember the Chinese are responsible for a fair share of it. It's kind of like, the arsonist maybe applying to, be a fire marshal or something. But that said, the technology works. The prototypes have gravity-funk satellites and nudge them into re-entry, and would also make a great space weapon to pull other countries' satellites down. But we won't go there yet. Because, the real concern is whose satellites they might start to quote-unquote cleaning up. Because let's face it, orbital salvage is one diplomatic incident away from space piracy. But meanwhile, inside the Tiangong space station, a crew celebrated the Mid-Autumn Festival in far more wholesome way. And why? Why is it the Chinese that brings me food? Not the Russians, not the Americans. I get space food from the Chinese. You know how much this pisses me off? Anyway, because the Mid-Autumn Festival is being celebrated, they decided to live stream a feast of spicy lamb mooncakes. They floated packets of chili paste and toasted Earth from orbit. I'm not going to lie to you, spicy lamb mooncakes actually sounds either A, something really delicious, or the name of the stripper I saw in 92. Could be either one. But in a way, it is, I'll give China credit, it is an oddly charming contrast. While their ground teams are playing hide and seek with launch schedules, the astronauts themselves are just trying to have dinner without drifting into the air filter. And somewhere in Beijing, there's probably a propaganda official insisting the meal represents, quote, the triumph of socialist cuisine, unquote. And honestly, sadly, because the frickin' Americans and frickin' Russians and everyone else who goes up there doesn't tell me what they're sending up in food, because space food is awesome, it kind of does represent a triumph of cuisine. Still, it wouldn't be an assholes in space segment if we didn't mention the competition. Yes, over in Russia, Vladimir Putin just approved plans to let private firms project advertisements from orbit. Yes, literal glowing billboards in the sky, fleets of microsatellites bouncing sunlight into recognizable logos. So, we have the possibility of looking at the night sky and seeing a Pepsi ad sailing past Orion's belt. And if you thought astronomers were pissed off at Starlink, I got news for you. Now, the ESA has called it a hazard to observation, and somewhere in Houston, a NASA flight controller muttered, of course, it's Russia that's doing this. Now, the official justification coming from Russia is new revenue streams for the space sector. Translation, we're poor as fuck and the ruble isn't what it used to be. So yes, we have China filling the sky with secret satellites, enjoying some spicy lamb moon pies. Russia is painting over the stars, and everyone else is just trying to keep clear signal to talk to their Mars rover. But there is in all the absurdity, there is brilliance behind some of the chaos. China's launching faster than any other country, more than 70 missions already in 2025. Now, I say nations because it is important to remember SpaceX is a private entity, even though it is heavily influenced by military and U.S. government launches. Most of the launches are private. Also, China's Tiangong space station is operating smoothly by all accounts. Their quote-unquote private to the government sector is growing, and their astronauts are live streaming holidays meals to millions and millions and millions of viewers. They're proving that propaganda and progress aren't necessarily mutually exclusive. You can cook dinner and conquer orbit at the same time. And yeah, there is a bit of strange charm in this assholes in space segment. They frustrate us, absolutely. They hide their schedules. They ignore orbital traffic laws. They kill cows with 1 out of every 6 launches, and they occasionally get to eat snacks on camera. I'm going to take a breath. Let's go into the next story, shall we? Now, we have mapped stars for millennia, and we still don't know if maps has edges. Some astronomers say the universe is infinite. No walls, no borders, just expansion forever. I call that kind of communist bullshit. Others think it's vast but finite, a cosmic balloon stretching as it inflates, where travel far enough in one direction might someday bring you back to where you eventually started. The current problem is we can't step outside to check. Not at all. We can only measure what light has had time to reach us. The visible sphere, the observable universe, is about 93 billion light years across, a bubble of everything whose light has arrived since the Big Bang, some 13.8 billion years ago, give or take a billion. Beyond that, we can't see, but physics suggests there is more. Maybe. Remember when your math teacher said the infinity symbol was wrong? But maybe there is a possibility of infinity. If it truly has no boundary, that means somewhere out there past the last photon, we can detect another version of us might exist. Maybe they're hosting this same show, wondering the same thing, arguing about whether to name their ship after a song lyric. Feeling seen by my own comment here. But infinity has a way of humbling even the loudest of civilizations. Finite or not, the universe does have a horizon. Cosmic expansion, driven by what we call dark energy, is pulling galaxies away faster than light can even close the gap. In roughly 100 billion years, most galaxies will slip so far beyond our reach that even their light will never arrive. Future astronomers will look up and go, huh, nothing up there. It's just a lonely sky. And that's why telescopes like James Webb and Hubble still matter so much to us. They're our lighthouses in the dark, sending beams both ways, outward in curiosity and inward in perspective. Now, Webb has already spotted light from galaxies formed when the universe was less than 1 billion years old. Tiny smudges that prove there was some order even amidst the chaos. Every proton they catch is a time capsule saying, hey, we're here. Some physicists, like those behind recent Space.com reports, have started asking whether information itself may be the real fabric of reality, whether space and time emerge from patterns of data. If that's true, infinity might not be a place at all, but a process, an endless computation, forever running, forever updating. And that just means consciousness, ours, yours, whomever's, is part of that process. We are not just in the universe, we are something the universe is doing. And that's admittedly part I can't shake. Every new discovery pushes the boundary of known a little further. But the effect is always the same. We feel a little bit smaller as the view gets a little bit bigger. It's as if creation keeps dimming the lights ahead of us just enough that we have to keep moving forward, chasing that next glimmer. Infinity is terrifying, sure, but maybe it's also mercy. Because if the universe ended abruptly, if there is a wall, a final coordinate, we'd lose the wonder that maybe drives us everything and everywhere else. The mystery is the motive. So maybe the answer isn't whether the universe ends, but whether curiosity does. As long as someone's still asking the question, the light stays on. And before we head to break, I do want to say hello to everyone in chat. Ordy, Aggie, I think I saw Delaney in there, and VC, and over at SHR, I see Kiwi and BZ. So thank you, everyone, for tuning in. I appreciate it. I think it's time we grab a drink, maybe stretch our legs, check to make sure, maybe our own personal orbit is still stable. When we come back, we'll drop back down to Earth a little bit, sort of, maybe, and see what the universe has been up to while we weren't looking. This is the Lost Wanderer podcast, and we will be back in 3 minutes.
I light a flame.
Intermission is now complete. You're listening to the Lost Wanderer podcast, and it's time for the second half of tonight's broadcast because the universe didn't stop expanding just because we decided to have a couple sips of our wine and take a break. Now, the fun thing about science is we always are learning new things. We keep finding planets that refuse to behave, for instance. Now, the newest culprit orbits a star roughly 1,200 light years away in the constellation Lacerta, and astronomers are, they're still kind of scratching their heads a little bit. It's what we call, and I wish I was making this up, a super puff world. Not a power puff world, a super puff world. About the size of Jupiter, but with the mass of a cotton ball. Okay, maybe not literally a cotton ball, more like 1/10 the density of water. If you could drop this planet into an ocean big enough to hold it, technically it would float. Now, this discovery came courtesy of the Subaru telescope. Now, not to be confused with, a Subaru dealership in Vermont where half the astronomer club parks a certain direction, if you catch my meaning, Mr. Frodo. But it was follow-up data that came from TESS, NASA's Transiting Exoplanet Survey satellite, that showed us more, that the light from the parent star dips rhythmically every few days, revealing the planet's orbit. Now that part, of course, is routine. What isn't routine is what the numbers said afterward. The planet's radius is enormous, but its gravity barely tugs on its star. It's like weighing a beach ball and finding out it's full of fog. Models can't quite explain how something so large and so light can exist without actually being torn apart. Now, right now, the leading theory is heat. Lots and lots of heat. Orbiting close to its star, this puffy world may be superinflated by constant stellar radiation, its atmosphere sort of swollen and leaking like steam from a kettle. And another idea is that it's young, still cooling from formation. Its gases have not yet compressed into a tighter ball. Either way, it's a reminder that nature doesn't care how tidy your spreadsheet looks. And now astronomers catalog these outliers with polite phrases like unexpected morphology. What they really, really mean to say, but aren't allowed, but I am because this is my show. What they really mean is, what the hell is that? Now, every time we think we understand planetary formation, some overachiever steps in and decides to ruin it. And we started with a simple model, small rocky planets near the star, with big gas giants further out. Then came hot Jupiters, mini Neptunes, and now this. Planets so fluffy they could double as parade balloons. And yes, somewhere the ghost of Johannes Kepler is probably rolling his eyes. But these anomalies actually matter. Each one stretches the range of what we consider possible. And that's how science survives, by being proven wrong in interesting ways, because science is never settled. For every new telescope image that matches prediction, there's another that doesn't. And that's the one that changes the textbooks. The James Webb Space Telescope has started peering into some of these atmospheres, searching for fingerprints of hydrogen, helium, and exotic molecules like titanium oxide. The more we look, the more chaotic it ends up getting. Some planets have clouds made of quartz. Others rain molten glass sideways at 5,000 miles per hour. Now, compared to those, our weird little puffball here seems downright polite. But still the question lingers, how stable can a world like this actually be? If it's bleeding atmosphere in the space, it may not last more than a few million years. A cosmic mayfly, if you will. One day its gases will thin, its core will shrink, it will vanish into a faint wisp of dust orbiting in an indifferent star. Yet here it is in this brief window of existence, bright enough for us to actually notice. A reminder that impermanence isn't failure, it's just physics doing poetry. Worlds come and worlds go, shapes form and they fade, and in between, someone with a telescope decides to write it down. So the next time you hear an astronomer talk about, quote, rules of planetary formation, unquote, remember, The universe itself never signed an agreement on what were the rules of planetary formation. The cosmos itself is more pirate than professor. And as we always say, the rules are always more like guidelines. Now, that said, Mars keeps getting all the headlines. But the closer we get, the more obvious it becomes. The hardest part won't be the distance, it'll be each other. A new study from NASA-funded researchers this month looked at crew dynamics in long-duration isolation missions, analog environments built to mimic a Mars base. The conclusion was simple, brutal, and probably familiar to anyone who's ever shared an apartment. You don't want 6 alphas on the same damn planet. The experiment ran inside the Human Exploration Research Analog at Johnson Space Center, using small mixed-gendered crews sealed in a 2-story habitat for simulated missions lasting up to 45 days. They tracked mood, communication, and cooperation using biometric sensors and daily reports. What they found was that the groups comprised entirely of dominant, highly competitive personalities, people who score high on traits like assertiveness and ambition, burned out the fastest. Conflicts rose, cohesion collapsed, and productivity nosedived by day 20. Crews with more diverse personality mix, however, kind of remained calm and efficient. Teams that included 1 or maybe 2 natural leaders, a couple of steady collaborators, and at least 1 empathetic mediator not only functioned better, they actually liked each other at the end. Gasp. In a way, it turned out space doesn't necessarily reward command, it rewards chemistry. Now, this isn't necessarily news to psychologists or chemists, but it's becoming more mission critical. A Mars expedition will trap people together for nearly 3 years round trip, 6 months each way, and more than a year waiting for the planets to realign. There's no door to slam, no way to walk to clear your head, and delay in radio signals means you can't even rage text mission control. If something goes wrong, it's on the crew to either fix it or fail it together. Now, this study echoes early results from Antarctic research stations and the Russian Mars 500 simulation in 2011, where isolation led to things such as fatigue, anxiety, and what the report politely called reduced emotional bandwidth and behavior. In other words, cabin fever with just a more scientific, better branding. So NASA's learning to engineer compatibility the same way its engineers actually do with hardware. Future astronaut selections will weigh empathy, patience, and humor right alongside endurance and IQ. Because when you are 200 million miles from home, the ability to tell a joke at the right time might matter more than, say, how much can you bench, bro? But it does raise a bit of an interesting philosophical point. We spent centuries designing machines to survive space. Do we have to design humans for it? We're kind of learning that the traits we once dismissed maybe as soft, listening, compromise, emotional intelligence, are maybe some strength that can be added to the structural material for going into space. And there is some saying among test pilots, check your ego at the hatch. For Mars, that might need to be etched right into the airlock as they enter. Because if humanity ever does get the chance to plant its flag on the red planet, the most important tool won't be the rover or maybe even the habitat or the radiation shield. It will be the ability to look across the module at someone who's driving you insane and still be able to hand them a wrench. Now, with that said, let's go out a little further to stars. Because every star dies eventually. Well, let me rephrase that. Every star dies eventually except Keith Richards, who was here before us and will probably be here after everyone else is gone. But for the rest of the cosmos, death is inevitable. It's just a question of how do you want to leave? Now, in a corner of the sky about 20 million light years away, the James Webb Space Telescope recently called a rare cosmic premonition. A red supergiant wrapped in a shroud of dust moments before it went kablooey. Astronomers have cataloged countless supernovae, but almost never the exact moment before. It's like catching a candle just as its flame turns inward. The star, known by its survey name SN 2024 ADW Hike, sat quietly in a nearby spiral galaxy when Webb's infrared eye picked it out in late 2024. It looked wrong. It looked too dim, it looked too dusty, it looked too restless. Follow-up images showed an expanding haze of material already escaping the surface. Within weeks, the inevitable happened. The outer layers collapsed, the core rebounded, and light from the explosion outshone the entire host galaxy for days. Now, much like red-headed women in our world, red supergiants are the drama queens of the stellar world. Yes, they may be pretty. We know they're going to blow at some point. They live fast, swell up to hundreds of times the sun's diameter, then spend their final centuries shredding mass like glitter at a parade. Most die without warning. But this one actually gave a bit of a heads up. A supernova, bit of a tantrum, visible throughout dust that only Webb's infrared cameras could pierce. By measuring the spectrum of that dust, astronomers confirmed it wasn't just smoke, it was chemistry in progress, because chemistry matters. By measuring the spectrum of the dust, astronomers confirmed it wasn't just smoke, which is awesome. Catching a red supergiant before detonation helped refine models for stellar death, giving us more warning signs to watch for elsewhere. For decades, we've had theories about how much material a star must lose before collapse. Now we actually have kind of the evidence A here in mid-act. Now, the event also highlights why telescopes like James Webb Space Telescope are rewriting astronomy and science. Once again, science is not settled. Where Hubble would see beauty, Webb is now seeing process. Its infrared vision cuts through obscuring dust to reveal the machinery beneath. There is a twist to this, though. The data actually suggests that this star knew it was dying. Stay with me here. In its last months, it was ejecting gas at a rate of 1,000 times higher than normal, as if trying to lighten the load before the final collapse. In astrophysical terms, that's actually could be considered awareness. Not consciousness, mind you, but a kind of physical self-knowledge written in equations of pressure and fusion. A star can't fear death, yet it still prepares for it. It spends its last energy creating the dust that will one day become something else. Planets, comets, maybe beings like us who look up and tell its story. Every telescope image of that fading red light is a reminder. Endings and beginnings often share the same color temperature. That ashes of one sun can become the dawn of another. And for centuries, we've tried to describe the universe in terms of what it's made of: matter, energy, fields, forces. But what if all of that is just a front-end interface, that the real operating system underneath is something simpler that we touched on earlier: information? Because this is a radical idea gaining ground in modern cosmology. Researchers studying dark matter with dark energy are beginning to suspect that information itself might be the fundamental ingredient of reality, the thing from which space and time will actually emerges. Now, the math is what started whispering this first. When you strip quantum mechanics down to probabilities, what you get isn't position or momentum, you get bits. Every electron, every photon, every field fluctuation can be described by binary outcomes: yes, no, spin up, spin down, 1, 0. The universe, it seems, is fluent in computer logic. And that actually led physicist John Wheeler to coin the phrase "it from bit." He meant that every physical thing, every it, arises from an informational bit. Matter isn't just data matter is just data that's been rendered. And the more we learn about quantum entanglement, the more that sounds less like philosophy and more like diagnostics, and where we get some conspiracy theories from. Dark matter and dark energy still make up about 95% of the universe, and we have no clue what they are. But if they're manifestations of hidden information, their ghostly effects start to make sense. It's simply data we can't read, influencing code we actually can. In a sort of weird way, gravity would be the emergent bug report of the cosmos. It also reframes one of physics' strangest facts that black holes actually do store information. When a star collapses, the data about everything that fell into it isn't destroyed. It becomes encrypted on the event horizon like a cosmic backup drive. That's actually Bekenstein-Hawking formula, the same math that links entropy and area. In a universe made of data, nothing truly disappears. It just gets compressed into unreadable format. Like Orty says, dark matter equals cobalt. Yes, yes. And I hate that makes sense. But here's where it does get a little bit weird. As well, as if it wasn't already. If information is the real substance of reality, then consciousness isn't an exception to the rule, it's part of the rule set. Every act of observation, every measurement, every awareness is a form of data processing inside the cosmic network. We don't just live in the universe, we're nodes in its ongoing computation. Which means when you stare up at the night sky, the universe, in a very real sense and really uneasy feeling, is staring back. Because you're both running the same code. It's not mysticism, it's math wrapped in metaphor. Every qubit that flips, every photon that travels, every atom that vibrates, and another line executed into the grand program of existence. Dark matter could be the hidden variables, dark energy, the unrolled recursion driving expansion. It could be 10, create universe, 20, repeat 10. The cosmos might not be infinite space, it might be infinite processing power. And that makes human curiosity feel less like vanity, more like function. We ask questions because the universe asks them through us, debugging itself line by line. Each telescope, each experiment, each midnight thought is part of the great compile. Somewhere between superstition and simulation theory, there's a truth that is taking shape. Reality is keeping perfect logs. Energy can't be destroyed because information can't be deleted. The past didn't vanish, it just is archived beyond our reach. So the next time you lose your keys, maybe you didn't misplace them. Maybe the universe just moved that file to different storage. Now, whether it's true or not, the idea does carry a strange comfort. If all of existence is information, even the smallest signal matters. Every word, every breath, and every spark of that thought is another bit of information written into the cosmic hard drive. Which means that somewhere in the great database of being, this little itty bitty broadcast, my voice, your signal, this moment is already recorded because the universe never forgets. So if everything is information, I guess it's time to process something truly mysterious, something scientists still can't quite categorize. Let's talk Uranus. I'll try to do this like an adult. Try is the key word here. Every few years, astronomers discover something new about Uranus, and the rest of us try heroically, if I may add, to get through the headline with a straight face. But this time the science is worth a Snickers. New data suggests Uranus and its blue-green sibling Neptune might not actually be ice giants after all. For that term dates back to the 1980s when Voyager 2's flybys showed both planets made of mostly water, methane, and ammonia ices under the hydrogen atmosphere. Cold, distant, quiet. Two frozen bookends to the solar system. Except new modeling drawn from NASA's Juno data and fresh high-pressure lab experiments paints a bit of a stranger picture. Inside Uranus and inside Neptune, it may contain far less frozen water than we thought. Instead, their cores may be packed with super-ionic fluids, matter so compressed that oxygen atoms lock into a crystal grid while hydrogen ions swim freely through it like electrical current. Somehow, that's not ice. That's more of a conductive nightmare masquerading as a snow cone. Now, temperatures near its core reach 8,000 degrees Fahrenheit, under pressure 2 million times greater than Earth's atmosphere. That is, well, if we're going to be technical, or actually not technical, but a derivative here, that's less frozen wasteland and more lava smoothie. But the new interior models also explain Uranus's weirdest quirk, its magnetic field. Unlike Earth's tidy dipole, Uranus's field is tilted nearly 60 degrees and offset from the planet's center. A sloshing, semi-liquid interior could twist magnetic lines like spaghetti. Neptune shows the same asymmetry, hinting that both worlds share the same chaotic core recipe. Now, why does it matter what's inside? Other than, the obvious late night jokes. These two worlds define an entire class of exoplanets. Thousands of worlds we found orbiting other stars fall into that size range. If Uranus and Neptune aren't truly icy, neither are they. It changes how we model planetary birth, migration, and atmospheric chemistry across the galaxy because science is not settled. And frankly, I'm going to say it, Uranus deserves attention. For decades, it's been the punchline of astronomy, despite having, 27 moons, 13 rings, and one of the strangest tilts in the solar system. It rolls around the sun on its side like a lazy bowling ball, its poles taking turns basking in 42-year seasons of daylight and darkness. And while it may look calm, its winds scream at 550 miles an hour faster than any Category 5 hurricane. Now, NASA does plan to send a dedicated orbiter in the 2030s. And I wish, oh my God, I wish I was making this up. The Uranus orbiter and probe. Yes, they're sending a probe to Uranus. Anyway, I'm trying my best. I'm trying to be the adult. Mission will map magnetic fields, probe the atmosphere, and maybe settle the debate once and for all about what lies beneath the pale teal haze. Until then, all we can do is model, observe, and giggle like a 12-year-old kid. Because if the universe does have a sense of humor, and I think it clearly does, I think it starts with Uranus. So yes, the joke will never die. And honestly, maybe it shouldn't. Because behind every childish snicker is a spark of wonder, proof that even after centuries of discovery, space can still make us laugh a little bit, maybe blush, definitely make us look at Uranus. So I think it's time. Let's dim the cabin lights, look out the viewport together, maybe look at Uranus together on pay-per-view or Pornhub. The next 2 weeks bring the kind of nights that make autumn worth the chill, clear, sharp, and full of quiet drama. The moon. We're just past a hunter's moon, which reached fullness on October 6th. The Abenaki people called it the Pinabaskas Kenzas, or the leaf falling moon. I hate my executive producer sometimes. Its glows linger long after sunset, perfect for the post-harvest nights when you can see your breath and your thoughts at the same time. Now, the moon is slipping toward a new phase on October 29th, leaving the skies wonderfully dark for any astrophotographers and viewers out there. If you ever wanted to see the Andromeda Galaxy without a telescope, this is your window. Around 10 p.m., look northeast for Cassiopeia's W, then trace a line slightly down and to the right. That faint, misty oval is M31. A trillion suns cruising toward us at 68 miles per second with an ETA of about 4 billion years. As far as planets, well, right now Jupiter is dominating the night now, rising just after dusk and reaching opposition on November 2nd, its closest, brightest point of the year. Even a small backyard scope will show its swirling bands or maybe show the shadow of one of its moons crossing the disk. Saturn is hanging steady in the southern sky with Aquarius, while Mars grows faintly low in the morning east, waiting for its comeback tour next spring. And if you're up early, why? Why? Venus still steals the pre-dawn show, so bright it can cast a shadow if you stand in the fresh snow. Because yes, some of us are experiencing snow. Right, Orty? We do have some comet and meteor updates. Comet Lemon 2024 S1 drifts near Virgo through late October, glowing faint green to anyone under dark skies. It may just scrape naked eye visibility, but even in binoculars, it looks like a cosmic ember tossed into the void. And this week brings us the peak of the Orionid meteor shower. I actually had to stop and think about that because, yeah, it's that kind of night. Anyway, around October 21st and 22nd, those streaks slicing through Orion's shoulder are fragments of Halley's Comet, still keeping its promise centuries after its last pass. You can expect up to 20 meteors an hour if you're lucky, or fewer if your neighbor insists on leaving the porch light on, because neighbors are bastards. So between Jupiter's glare and the hush of the new snow and the shimmer of the comet dust, these will be perfect nights to remember why we look up at all. And as always, maybe take a moment to look at Uranus one more time. Just don't film it and put it on OnlyFans. So step outside, find the big square of Pegasus, follow to Andromeda, and just breathe for a moment. Every photon hitting your eye tonight left their home millions of years ago, only to arrive right on time. So that's it for tonight's transmission. Thank you for tuning in whenever and however you do. Special thanks to NASA, SpaceX, Space.com, Ars Technica, NASA Spaceflight, Popular Mechanics, and everyone out there keeping humanity's eyes on the stars. With me at the helm and the executive producer plotting our next course, and with the ship's computer in the back whispering star maps through the static, this has been the Lost Wanderer podcast. Until next orbit, I do hope you enjoyed the show, learned a little something, and maybe, just maybe, had a laugh or two as well.
The universe is a pretty big place. It's bigger than anything anyone has ever dreamed of before. So if it's just us, seems like an awful waste of space. Right?